Hello everyone. In this video, I am going to discuss about spherical mirrors. Okay, so look at this diagram carefully. The first one is called concave mirror and the second one is called convex mirror. So here concave mirror means here the inner region is the reflecting region. That means outer region is opaque medium. It doesn't allow the light. Say for example, uh, when a ray of light which is directly incident on the concave mirror, after reflection, the reflected ray is directly passing through the focus. Suppose when another ray of light which is directly incident on the concave mirror, again the reflection will takes place, the reflected ray directly passing through the focus. So by seeing this diagram we can understand after reflection the reflected rays are meeting at point F, right? Meeting at point focus. So we can say that concave mirror is the convergent mirror. All the reflected rays are coincide at a particular point. So we can say that concave mirror is the convergent mirror. Okay. Now coming to the convex mirror, that is mirror 2. So in the case of convex mirror, this is the outer region, right? This outer region is the reflecting surface. That means inner region is opaque medium. It doesn't allow any light through it. See for example, when a ray of light which is directly incident on the convex mirror, after reflection, the reflected ray will move like this. Suppose if you're taking one more incident ray of light like this, after reflection, the reflected ray is moving in this direction. So by saying this, yes, we can able to understand after the reflection, the reflected rays are diverging, which was moving in different directions. But if you're drawing the imaginary lines of reflected rays in backward direction, these reflected rays coincide at the focus. Similarly, this one also coincide at the focus. So we can say that convex mirror is the diverging mirror. Concave mirror means convergent mirror. Convex means divergent mirror. Okay. So here I mentioned here capital F is focal point or focus. Small f means focal length. C is called center of curvature and P is called pole. Okay. Now coming to the general terms. So see here. So the first one is pole. Now let's see the diagram. In the case of concave mirror, one second. In the case of concave mirror, so this point is called pole. So we can say that it is a midpoint of the spherical mirror, right? So this point is midpoint of the spherical mirror. Similarly, in the case of convex mirror also, this is the convex mirror and this point is called midpoint of the spherical mirror. Okay, so pole is nothing but it is a midpoint of the spherical mirror. Okay, now look at the diagram carefully. Here we have capital F. This capital F is called focus. Similarly, in the case of convex mirror also here, F was located here. This capital F is called focus. What is the meaning of focus? Look at the diagram carefully. After reflection, the reflected rays are passing through the F is called focus. Similarly, in the case of convex mirror also, after reflection, the reflected rays are diverging like this. But the imaginary lines was coincide at the focus. Okay, so after reflection, the reflected rays are meeting at a particular point. That point is called focus. Okay, now coming to the focal length. What is the meaning of focal length? Already we know the location of the pole. So the pole location is here and focus location is here. The distance from pole to focus is called focal length. It is denoted by the symbol small f. Similarly, in the case of convex mirror, the pole location is here and focus location is here. The distance from pole to focus is called focal length. Okay. Now coming to the next general term, that is center of curvature. So look at the concave mirror here. We have a capital C here. That is called center of curvature. What is the definition? If you have a sphere like this, yes, there must be center will be there, right? Correct or not? One second. Yes, So there must be center part will be there. Similarly, the concave mirror means if you are extending like a mirror, it looks like a sphere, so there must be center was located here. Okay, center of curvature means it is a center of the sphere. It is a center of the sphere. Similarly, in the case of convex mirror also, center was located here. If you are extending this convex mirror like this, it looks like a sphere in shape, right? So if sphere is present means there must be the central part is called, the central part is nothing but center of curvature. Okay, now from pole to center of curvature distance is called radius of curvature. 1 second, I will show you in the diagram itself. Just a second. Yes, thank you. So I told you already, this is the location of the pole and this is the center. From pole to center of curvature distance is called radius of curvature, or similarly in the case of convex mirror also I will show you the radius of curvature position. Look at here, this is the pole and this is the center of curvature. The distance from pole to center of curvature is called radius of curvature. So here I mentioned the definition also. The distance from pole to center of curvature is called radius of curvature. And look at the diagram carefully here. The pole location is here, center of curvature is location here. So in between pole and center there must be one more point is located, that is called focus. So this focus distance is exactly half of the radius of curvature. Okay, so that's why I mentioned here last point, radius of curvature is 2 times of focal length. So r is equal to 2 times of focal length. So from this easily we can calculate focal length. So f is equal to r by 2. So focal length is equal to half of the radius of curvature. Okay, I hope you understand. If you really like my video, then subscribe my channel Physics Hunt 3. Thank you so much.